episode of Elements of Interest with Josh Burkhalter. How you doing, man?
I'm good. Um, Soon as we're done here, immediately taking off. I'm gonna go grab my daughter. We're gonna go out for her birthday. Get into a little bit of trouble maybe. Um, so yeah, it's a good day.
All all right. Well, what better pregame than talking about fuels, huh?
Oh yeah, yeah. I've been looking forward to this one.
Yeah, you know, you just gotta. All I need is a little bit of idea seed, and when you posted about jet fuels the other day, thanks to that aircraft display that you got to enjoy since last week. Yeah, why do we even need this stuff? Why do
Mm.
we even need all the different fuel types? And why is it important to know that they are different and how they're different and that, the people manufacturing them uh, are kind of, making the right thing at the right time for the right people. I think that's what this materials analysis stuff, quality control is all about. So I figured let's bring it back to some of the why are you even testing this stuff in the first place. So why is this so important, like testing our materials, this material quality in this case?
It's a big question.
It is.
Um, so start with answering this kind of in a general sense. Maybe for some non-technical people. All right, so when we think about the different fuel types, like there's not a well-defined industry standard for that, right? But like just logically, what are the fuels I think of? We talked about the air show, so jet fuel, right? So fuels that go into um, turbine jet engines, we call that jet fuel. Um, there's a different type of fuel that goes into like prop planes. It's called aviation gasoline or avgas for short. That's a different type of fuel for a different type of engine. So different type of applications, how are the fuels consumed, what are their purposes, start to dictate maybe what are the different types. The one that most people are most familiar with would be gasoline. For those in Europe, I suppose you call that petrol. Um, so gasoline is a fuel that goes into an internal combustion engine in small motor vehicles, and then diesel or number two fuel oil would be another type of fuel that's quite common. So that's usually a little bit heavier duty usage, right? So, truckers, large trucks, and then many other applications, right? So that's kind of the general, most commonly accepted categorizations of fuel types. Okay, so why do we test these things and what are the purposes of test? So, Chris, let me ask you a question. Did you know that there's a book called The Significance of Petroleum Tests?
I did not know that, actually.
Yeah, most of us don't, or if we did, we've kind of forgotten over time. Um, so it's available on Amazon, by the way, and it's also available as a PDF on ASTM's website, like wherever you would normally purchase your ASTM standards from. Um, I, it was a great tool as a lab tech and as someone who is training lab techs to understand not just the procedure of what they're doing, but the purpose of the test that's being performed so they can understand the context um, behind what they're testing for. I thought that was quite cool. And then everyone in the industry, not just those that work in testing, but those that review certificates of analysis for, um, making sure that the specifications pass, or who are making commercial decisions, right? Like understanding the significance of the testing, I think is quite helpful. So yeah, what are the types of tests and their purposes, right? So I immediately think of something like safety. So there's a test in diesel and other heavier fuels that will often be stored and transported um, at higher temperatures. And, so there's or, not necessarily they're transported and stored in higher temperatures, but they often can be, I should say. So there's a test called flash point, right? So it's the point at which products under certain conditions the vapor will cause a flame to ignite. So if you think about that from a safety standpoint, right, we want to make sure that the fuel's not stored at a temperature that's going to get anywhere close to the point at which the vapors start to create a fire hazard. And then there's environmental conditions, right? So the EPA, for example, we talk about them a lot. They put standards in place for certain levels of sulfur or benzene or other hazardous materials and components that might be in a fuel or another sample. So they've got specification limits for those tests to ensure that they don't exceed these conditions that are deemed hazardous to the environment, human health, that sort of thing. And then stability, right? So can you store this material safely and for a long enough time that, when you go and start your lawnmower next summer, well, for those of us in Houston, we don't stop cutting our grass, right? But in the winter, right, the northern states right now perhaps aren't going to be cutting their grass for a while. So is that fuel going to be suitable come March, April when it's time to dust off the lawnmower? So there's tests for things like that, where you simulate storage conditions, kind of an accelerated. You can't store gasoline for or you can, right? But it's not practical to store gasoline in a lawnmower in a laboratory for 6 months and then test it afterwards and say, oh yeah, that fuel's good. You guys can use it now, right? So you find test procedures that can simulate severe storage conditions to test that the fuel doesn't break down. It still has the same characteristics. Okay, let's keep going. I got a couple more. So we've got to make sure that the consumer is protected. The consumer's engine and fuel system is protected, right? So there are things like the gum contents of jet fuel and gasoline. So gum is a colloquial term for a sticky resin type material, for lack of a better term, that will form under certain conditions, and it will foul the injectors and it will clog up the storage fuel lines and things like that, right? So there's tests to determine that it's going to not harm the equipment. And then there's the things that we're most familiar with and think about. And those are the things to make sure that the fuel is fit for the purpose, so fit for use, and it's going to perform, right? And that's very often where a lot of the test is focused. A lot of the testing and the specifications are focused around. So the octane number of gasoline, the volatility, right? So is it going to perform well under the conditions of the engine during that season and temperature and barometric pressure, et cetera, right? So that's a long answer, but there's a lot to that, right? So maybe I'll turn it back to you and see if there's anything around that you want to unpack a little bit more.
I think you bringing up the context, like, and why that can be helpful to a lab tech or anybody else is important. It's insightful because most most manufacturers that I've run into, as far as instrument manufacturers, like there's this endless journey towards green light, red light, like instrumentation, in terms of we don't. There's also the other side where companies are not wanting to invest in talent for analytical science and the knowledge required to, maybe understand the context and how the tests work and the theory behind it and all these things. So we try to make this equipment that's like just push the button, just fill the cup, right? But then if you don't have any of this context, if you don't have this information, like it's just really hard to do your job sometimes, right? So it removes kind of critical thinking. And then when anything goes wrong, like somebody around has to know like what's going on. Uh, so it's always been interesting to me that manufacturers like try to take that angle instead of, maybe training or focusing on like adding this context. And that's where some of these whys, and I know, I think we assume a lot at various levels of work, of the workforce, like what they care about, what they don't care about. And, I found that some people, when you break it down, because usually I'd say most people know of like two things related to, uh, fuels, and that's maybe like crude oil barrel pricing news or whatever they hear on the news about
Mm-hmm.
that, which is the complete other end, or whatever they see at the pump, right? Different
Sure.
octanes and the costs, right? But there's all these things in between that is either taking stuff out or putting stuff in to make it work for cars, for jets, for all these things that Josh was mentioning. And ultimately, there's measurement variables related to all those different things that, uh, we're testing for throughout the process. And that's where just sometimes just a small amount of knowledge can help somebody. Well, this test looked like this over here. Why wouldn't it be the same over here? And like, why do I have to think about a different number when it looks like I'm testing the same
Mm,
thing, right?
sure.
Am I overthinking that?
No, no, not at all. There's so many things that you mentioned that I want to kind of respond to. I'll try to limit that, right? So yeah, so I'm thinking of examples in the laboratory, right? So there's an assumption that the machine just gets the number for you, right? And then it's the right number, and you just report it, and the job's over. And that would be wonderful, if it could work that way. Um, and you're right, right? So I think we right, collectively, we focus on procedurally. What's the procedure? Is the instrument capable of running the procedure? Is the instrument qualified? It's all about the instruments. And then push button, get banana, right? And there's just an overwhelming number of factors that can impact the precision and the accuracy of a measurement system. And so all of those things that we think about and have been talking about in the context of QC, all right, or SQC, well, the whole point of why we're doing that is so we can identify those factors and start to eliminate them from causing variation, those quote unquote bad results or those biases. Okay, well, we did our best, and then we go and run samples that we don't know the value of because they're not the QC we run every day. And yeah, the QC is kind of it's a proxy system to make us feel more confident that each test that we run is correct, but we don't know, right? There is variability. There's always a possibility that something goes wrong between the last time we ran a valid QC. And so what are we equipped with to ensure that the result that we produced on this quote unquote blind sample is good? Okay, well, is it within the specification limits, right? Does it meet the min or the max or the range that are required, according to the product spec that we're testing according to? Okay, cool. It's within the range. Great. That's step one. Um, but it could be within range, and we always assume it's within range, so it must be the right number and it's good. Well, I mean, maybe it wasn't within range. Maybe we didn't get the right answer. So that's maybe not the only thing that we want to look at. Um, what is this product typically, what's the typical range of this results for for this property, for this product, from this customer when they load it from this location, right? It's more about the context. So kind of this idea of trending results, right? We trend the control chart, right? Well, we can trend analysis, right? And so if a laboratory is testing in a manufacturing setting, they very often can predict what results are supposed to be today based on how they've historically run, right? What was it yesterday and last week? And is it within a reasonable range according to what I would expect, assuming that the process is still the same and you're still making the same product and that sort of thing. Okay, cool, that's great. Um, but there's some other things, right? There are properties that are related to one another, right? As one value goes up, another test result value may go up with it or down, right? When we think about like the specific gravity of a fuel, um, how dense it is or density, well, that tracks with some of the composition, right? So, as gasoline, for example, as the aromatic content goes up, typically the density goes up, right? Because the aromatic compounds are more dense than all of the other component types. So there's a correlation here. The higher the aromatic content, typically, again, this is an oversimplification, but typically the higher the octane value. So then you have to understand these interrelationships between properties. And then you still have this whole idea of like, why are we even testing this property? Why do I even care? And so that's one thing I want to pick out a little bit. So as I've grown up a little bit, and gotten a little bit more perspective after 25 years of working, I didn't know for a long time kind of why I worked, right? Like, besides the obvious, right? Why did I do things? What was like my connection to like this greater purpose? And I've learned over the years, for me, it was serving. And I found that no matter what job I had, what industry I was in, the types of activity as I was performing and who I was doing it for, like that was my common thread. Okay, well, let's suppose you work in a factory and you make widgets, right? Or ball bearings. Well, who cares, right? Like you're just making metal balls, right? Like it's like, what's the big deal, right? Okay, or you make rubber. That's just these pellets of rubber, and someone's going to go do something with it later. But also then when you get in your car and you take your family to dinner, and you're driving around in your vehicle, and there's ball bearings and there's rubber and there's these and that things, and there's plastics that are sat in the sun that are 150 degrees, and there's these volatile compounds that you were supposed to test at work to make sure that they're not in the dashboard, so that you're not huffing these chemicals while you're driving around, right? It's like, okay, well, things become a lot more significant then. And so those were the types of like realizations that I started to have. Quite embarrassed to admit this, but it took me a couple of years of working in the lab before that type of thing started to click. But when it did, right, like my focus and the amount of energy that I put in personally in assuring the quality of results, into looking at how things fit together and finding those patterns, it became like kind of like a game. It was like a puzzle to figure out. It meant a lot more now when I hit what used to be the fax, right? But then when I hit the email button to send that certificate of analysis to the pipeline so they could move that product, right? It meant a whole lot more when I thought about it in that context, right? So there were some other things you mentioned I think I wanted to respond to, but I've already forgotten what they were.
Yeah, I got to work on the back and forth and better parse it out. Um, no, but I think like understanding, especially as it relates to, you got different materials, different fuels in this case coming in the lab, and like the understanding of the process, which even I worked at ASI for quite a long time before I understood it exactly, like the whole crude oil process and why are we selling this to these customers and not to these customers, and understanding how, like, if this customer is testing this, then that probably relates to what this, customer is doing, but then also watching them not really talk to each other about the changes that they're making and how they're doing things, and it's messing up this testing over here. Like the the taking stuff out of the material and then putting stuff in is just a really interesting like component. And sometimes it's like, at least for me, I was like, I wanted to protect the little guys sometimes because they can be doing a great work, and the Exxons of the world, is they have all of the data and they've been doing this for 30 years, so they generally have the leverage in cases where there's discrepancies of testing. And so often it ends up being like, oh, this test's too high, you get paid less now, like for the job that you're doing for me, or the material that you're giving me, right? Because now we got to figure it out, and there's so much of that handoff when it comes to materials. And that's, you know once I understood the what are we trying to do to refine, like, I guess from a take stuff out perspective, like sulfur starts at this percentage and we're trying to get it down here, but then also like adding octane, right? And stuff like that, where it's even in metals, like you start to understand like it's in the business's best interest not to add too much of the super expensive thing, right? So you're really unlikely to see like the bottom of the range, but you should be keeping a real close eye on, the top of the range. I think I said that backwards, but things like that can help you do, like, okay, something might be wrong here. What are the first steps I could look at? Because otherwise, when it is the push button get banana thing, like you mentioned, it's like, all right, something's wrong. I've got to look at everything, right? Like there's no like quick, oh, it's probably this, or they probably mixed batches, right? Because this is clearly a different type of fuel because all these things are off, right? So yeah, that part, I don't know if that jogged the memory at all, but this just understanding the process of creating the stuff, right?
It's funny. You're like, I said I kind of forgot what my other point was going to be, and then you immediately brought it up again. I was like, oh, that's kind of cool that he did that. So, the take things out and the put things back in, right? Like, I mean, in real plain language, which is what we should be using, that's what this game is all about. That is what's refining. Um, it's a little bit fancier at times, but like as you're talking, I've never thought about it in this way. But an analogy that immediately comes to mind now is cooking, right? You're making a pot of chili or whatever you like to make. You taste it, right? And that's the testing, right? That's the test slate that you run, and it's like, where are all of my numbers? And you taste the chili and you just intuitively know that it needs a little bit more salt, or it needs a little bit more time, or and not the ingredient, but time on the
Could
stove, right?
could be the ingredient.
Sure. Don't give me no chili with time, but we'll have a problem. I'm not a can't have beans guy because I'm in Texas. That's a whole big thing. You can put beans in my chili, even white beans. I eat a white bean chili. In fact, I eat, yeah. Anyways, but thyme, we're not doing thyme in my
Okay,
chili.
that's fair. That's fair.
But yeah, and in the laboratory, right? They'll do so in a refining process, right? Very often, like the recipe, and they even call it that, right? Like, duh, they call it a recipe. It's the blend recipe, and it's the plan, right? It's the ingredients that they're going to put in from this unit, da 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 da, and these concentrations, and at the end, they're going to mix it up, and they're going to bake it, and they're going to taste it. And in a lot of the laboratory work that I did, we worked in a blending operation where it was like not inside of a refinery, but it was someone outside the refining that would go and find materials, and they would source it, and then they would plan a blend, but it was a very much a piece by piece, right? They'd buy a truck of fuel and a barge and and they would assemble it, and we would do a prelim test because they didn't want to make it too good yet, right? So we do a prelim test, and it's like, oh no, it's missing some salts, right? Or, you know what? Like the vapor pressure's really low, which is a good thing, right? It's not anywhere close to the maximum specification. Okay, well, vapor pressure giveaway is a huge no-no from a profitability standpoint. There's always something that has higher vapor pressure that you can dump in there that's cheaper, right? And so you can still kind of work up to that specification limit with a cheaper filler material. It's still completely safe, right? It doesn't have an environmental concern. It's not going to gum up the engine. It usually may not even have a negative impact on any of the other properties, but you have specifications for all of those, right? You're not doing anything that you're not supposed to be doing. You're optimizing, right, the barrels of component material that you're putting into that blend. So a little bit of salt, a little bit of time, that sort of thing. That's exactly what it is. And yeah, and then the takeaway, right? Yeah, you want to take away the things that are harmful, or the things that are foreign. And it's interesting, right? I'm not sure if this is really relevant, but it comes to mind. So the EPA, I think in industry we could debate their effectiveness in helping the environment. Some people have very different opinions. I'm kind of neutral. All right, like I just try to understand the requirements and help people live with them. But one of the things that came about many years ago, when I was responsible for a diesel and gasoline testing laboratory, is that the EPA mandated ultra low sulfur diesel, and which that meant sulfur. There used to be high sulfur or higher sulfur in all the diesel fuels that we burned, and they said, we really need to reduce that. So it needs to go down to a level, and they called it ULSD, ultra low sulfur diesel. And I don't think anybody knew this or didn't predict it, or an unintended consequence. It started to foul engines, right? So in a diesel engine, unlike gasoline, right, a diesel engine relies on the fuel itself to lubricate some parts. And it lost some of the lubricating properties that the sulfur, evidently the sulfur provided. So when you strip the sulfur away, it just eroded or degraded just enough that we started to see engine fouling. So it created this for us in the laboratory. It created this entire new testing offering that we needed to make, which was a lubricity machine, right? So now it was like lubricity was like the hot topic, right? And we were one of the first labs that got it, and we were running them all day, and everybody with an engine out there, typically not like road. It's not the guy that has the F-250. It was the farmer and whatever that had more expensive equipment, sending samples all over, and we're testing hundreds of these. And we find, we didn't find it, right? It was found and became part of the norm. And now it became this new specification that the lubricity had to be a certain level. And no ULSD ever passes without adding something back now. Right? So you have to add what's called an additive, right? It's like, wow, we've come up with these really simple terms that make sense, right? So it's just a chemical component that enhances the fuel to some desired result. In this case, it just made it more lubricating, for lack of a better term. It's interesting that you said it like that. You've triggered me to think in a way that I've never thought about for 25 years. So I'm going to think about this as cooking chili, and we're going to add stuff in and take it out.
Yeah, and literally like salts sometimes are
Yeah.
involved.
Literally. Yep.
And yeah, so it's it is interesting to think about because they use a lot of similar terms, like blends and recipes, and and things like that. But, if you're, I just like things that comes to mind are like just all the environmental factors, um, and a lot of the variables that you mentioned about why we're testing. Like if I'm in the Upper Peninsula of Michigan in the winter, and am still, I have not switched to the 5W, 30, or the thinner uh, lubricating oil, then I might end up, having problems with engine
Yep.
start. And like most of these things are like fuel is expected to help something else go, right?
Yep.
Literally. And when it's not the good stuff, that's when your car stops working. All the machines stop working, stop doing what you want, or they deteriorate like really quickly. I'm sure is more often the case. But yeah, it's just a super interesting ecosystem. And again, like if they weren't caring about like the costs and the profitability, like and they just, never change the supply chain, and there's all this buying and selling. It's super interesting. Probably not for everybody, but uh like if they didn't care about that, like we would feel it at the pump, right? It would just like get transferred to us. Like somehow the cost of doing that, the cost of creating the thing, if it went up that day, like we would feel it. Instead, there are people like saying like, all right, this is cheaper over here. Can we make the thing to spec now, like, so that it doesn't have like this wide-ranging impact? I'm sure they're not all altruistic like that, but I know some are for sure.
Well, yeah, yeah. There are clauses. There are like workmanship clauses, right? So even though it doesn't letter of the law get spelled out that it cannot contain this or it must contain that or meet this specification, there are workmanship clauses in the ASTM specifications that are referred to, right? Um, and there's typically those types of clauses that are in contracts between buyer and seller. And these brands now, like the idea of ending up on the news, especially with how fast news travels now, it's not worth, right? Generally, it's found to be not worth even trying, right? And so maybe that wasn't the case 20 or 30 years ago, but I'm not seeing, at least from my vantage point, people really, really trying hard to skirt the edges too hard.
That's good. That's good. So that means the only concern is helping people understand that. Helping understand like because the mistakes are where we do the job then in terms of testing. Like people do make mistakes, and it doesn't take too many YouTube searches. Like if you want to find out what happens when stuff is not made correctly, uh, uh, whether it's metals or fuels or lots of different materials, like it's the things that you end up seeing in the news are really tragic, and people can get hurt. And but usually, like so often, like some process was not followed or some material was not up to spec and the test missed it or it wasn't tested, and somehow like the thing that was expected to happen did not happen, and it caused catastrophe. So
Yeah, a quick note about that. Yeah, yes, in these tragic circumstances, right? It very often, at least one of the causal factors was a human made a mistake. Um, but like that's not good enough, right? And the industry has through regulation, through self governance, through protecting your own brand. I feel the industry is much magnitudes better at looking at the engineering controls and the redundancies and proactively doing the safety walks and the triple checks and the opportunities to prevent things rather than reacting and chalking it up to human error. Like Like that's not really the mindset that's prevalent. Again, perhaps it was different in the past. Um,
Right.
yeah, we had a situation in my hometown a couple of weeks ago with an H2S, a high H2S material release. Two people passed away, many more injured. Um, yeah, you hate to see it. I don't remember the root cause of that. That's probably not from a testing. It probably wasn't impacted by testing. But if we're not learning from every situation, right, and just looking and making sure our house is in order, then like what are we doing here?
Yeah. And really everybody in every lab like plays a role in all this at some point. So at the end of the day, hopefully that why, helps people understand like there is yeah, it's a good book I need to check out. The significance of all this. There is significance. Um, we're not just doing it because the auditors told us we had to, right?
Yeah, yeah. We can get by. We, right, for the most part, 99% of the time could probably get by without understanding the significance. Um, but it's that last 1% when we miss the thing that we could have not missed if we had the context. That's when it really really matters.
Yeah, and that's why we're here. Uh, so hopefully this was helpful. Uh, look forward to doing more of these. We're gonna, hopefully get some other people on the schedule soon. Getting some other takes, other voices throughout the space. I know there's a lot of people out there that like talking about this stuff, like sharing knowledge. So we look forward to getting more voices on the show. But until then, everybody have a wonderful week, and we'll see you next time.
All right, thanks, Chris.